All right, on page 539 today, up there at the top, we've got the geometric mean theorem. And the geometric mean theorem is very wordy. So we're going to simplify it by shrinking it down to basically a formula. So let's draw that triangle that's in the box with 8.2. And it's a right triangle that looks like this. And this is triangle ABC. Our right angle is at angle C. And then out of that right angle, we've got an altitude drawn to the hypotenuse. Same as yesterday. And your second and third right angles are right here. We're going to call that point D. Now, for this part of the theorem, we're concerned with the length of CD, which we're going to label H, A to D, which we're going to label X, and D to B, which we're going to label Y. This is H is the altitude drawn to the hypotenuse. We talked about it yesterday. Altitude drawn to the hypotenuse in a right triangle. That distance, H, is equal to the square root of X times Y. The altitude drawn to the hypotenuse is equal to the square root of the product of the two pieces that it creates. Okay? Before we drew in CD, all right, we just had one right triangle, one big right triangle, and it had a third side to it. But when we drew in that hypotenuse, or when we drew in this altitude to the hypotenuse, we created two segments. All right, so the length of this altitude is equal to the square root of the product of those two segments. All right? Second part of the geometric mean theorem. Let's add a lowercase b right here. A lowercase a representing side CB. And then this overall distance right here. All of AB. We're going to call this lowercase c. What we're going to say now is the length of A. The length of A is equal to the square root of y times c. In your big outside triangle, the original triangle, the length of this side, A, is equal to the square root of the product of the piece of the hypotenuse closest to it times the entire hypotenuse of the original triangle. And then lowercase b, which represents side AC, is equal to the square root of this piece of the hypotenuse, x, times the entire hypotenuse, which is c. So I don't know how you memorize things, but the way I memorized it was, and you know how I'm not telling you to write this down because for some people it's just a lot more confusing. I just remembered kind of a picture of this is equal to the square root of that times that. That this piece is equal to the square root of this times this. And that this piece of the original triangle is equal to the square root of this piece times the entire piece. Now, that diagram works for me. I don't know what's going to work for you, but you are going to have to memorize this for your quiz on Friday. All right? So hopefully by doing enough practice problems, you will have it memorized, or you'll find a method for memorizing it that works for you. So let's look at example 3 right now. And we're going to solve for all of the variables in that triangle. So we've got something that looks like this. And we've got an altitude drawn to the hypotenuse. And we've got a piece that's 5 and 20. We've got z, x, and y. And we have to solve for these variables. So when I get this picture, the first thing I do is I put this piece in here. All right? The entire length of the original hypotenuse, and that's going to be 5 plus 20, which is 25. So if we go back to the formula, our x in this case represents the h from the previous picture. So our x is equal to the square root of these two pieces, the product of 5 and 20. So x is equal to the square root of 100, and the square root of 100 equals 10. Z, or I'm going to do y next. Y is equal to the square root of, okay? Y is equal to the square root of this piece times the entire piece. Okay, so y equals the square root of 5 times 25, which is the square root of 125, which is equal to, leave your calculators set on second fix 1 as they were yesterday. So we're going to go 125 square root, and that's 11.2. And then z, which represents the third side of the big triangle around the outside, our z is equal to the square root of 20 times 25, which is equal to the square root of 500. And the square root of 500 is equal to 22.4. Any questions on any of that? All right, turn the page, look at the guided practice on the top of 540. That's problem 3A. Let's get that triangle drawn. All right, again, we're going to take this entire hypotenuse, and the length of it will be equal to 8 times 25. No, it won't. It's 8 plus 25. That whole hypotenuse is equal to the sum of those two, so that's 33. So our z is equal to the square root of 8 times 25, which is the square root of 200, which is 14.1. Y is equal to the square root of the piece right around the corner, 25, times the entire hypotenuse, which is 33. 825, square root of 825. And 28.7. And then for x, the left side of the original triangle, x is equal to the square root of the piece right around the corner, which is 8, times the entire hypotenuse, which is 33. And 8 times 33 is 264. And the square root of 264 is 16.2. Get the idea? Right? And let's look at the second guided practice there. We've got this right triangle. And now we're given this altitude drawn to the hypotenuse, so it's equal to 12. And we've got an x here and a 9. Y is right here. And z. All right, so right now we can't find the length, the overall length of this hypotenuse, because we're missing the x. All right, so we're going to set up the formula. We're going to say that 12 is equal to the square root of 9 times x. Now, in order to eliminate the radical, you square both sides of the equation. Okay? So we take this, I put it in parentheses, and I square it, and then I take the 12 and I square it. So 12 squared is 144 equals the square root of 9x squared. All that technique does is it eliminates the radical. So the square root of 9x squared is 9x. And now you can divide both sides by 9. And 144 divided by 9 is 16. So our x is equal to 16. And now with our x being equal to 16, that allows us to find this entire hypotenuse. So 16 plus the 9, that's 25. So now we go back to our formulas, and they say that y is equal to the square root of 16 times 25. And 16 times 25 is 400. So y equals the square root of 400, which is equal to 20. And then our side z is equal to the square root of this piece right around the corner, or right around the vertex, 9 times the entire hypotenuse, which is 25. So the square root of 9, we got 9 times 25 is 225. And the square root of 225 is equal to 15. Any questions? All right. So that's the geometric mean theorem and how you use it to solve for side lengths and right triangles. And then your practice for today is going to be on page 541, problems 5 and 6. And then over on the next page, 18 through 23. And we'll leave it at that.